Welcome back to Basement Math Lab. Today we are going to be learning about difference of cubes, I believe it's called. So, it's very likely that you have come across one of these questions and you had no idea what the heck to do because we have one expression right here. 108z cubed plus 2048. Sorry. And you might have been thinking, like, well, this looks like a difference of squares, but it's not. It's actually what it's called is a difference of cubes. So, this could be something that was like trying to stump you, and yeah. So basically, this is going to be a tutorial on how to deal with these kinds of questions because it's a little bit very slightly complicated, but it's nothing too bad. So the first thing we do is step one. We check for a common factor, right? Now, if you look at this question, it'll be a little hard to find the common factor. But since I made it up, I know what the common factor is, and it's actually 4. And so we're left with 27z cubed plus 512. So we always have to check for a common factor when factoring, and we found one. So it's 4. So both of these numbers can be divided by 4. So pretty nice. You should probably develop a strategy to find common factors. Usually, what I do is I will go 108. I'll get the number, and then I'll just divide it by increasing numbers. Right? 1, no, 2, no, and then 3. Right? Like I do this when factoring, right? So with the product and sum method, you can always you can see with the product and sum method, right? If this number and this number add together to get your to get your sum, then you can just do that, and it makes it a little bit easier. I'm rambling on, but yeah. So we found the common factor, right? And now we have to determine if the values are cubed values, right? And you can do that on your calculator because you will have a handy little button right here. This x and then square root symbol, right? So what you want to do is you want to click 3. 3 is going to always happen. And then for me, I click second like this, right? So you'll get something like this. So 3 and then x and then the square root bracket. And you can throw in 27 because that is our number right here. And you do that and you get 3. So 3 cubed is equal to 27. And we can test that, right? 3 times 3 times 3, because 3 cubed is just in expanded form. It's 3 times 3 times 3. And you get 27. That's a nice little function you can use on your calculator, right? So 27z cubed is positive 3z. It has to be positive because this 27z cubed can also be negative, because in cubed things, like where it's 3 numbers multiplied by each other, if you have 3 negative numbers multiplied by each other, they can equal a negative at the end. It's not like squares where 2 negative numbers will still get you a positive answer, right? A positive value. So you have to make sure to have the plus there. This is positive. And then 512, I'll show it again on the calculator. 3, and then second value this, and then 512. So you do that for both numbers, we get 3z, right? Because the z is cubed, we can just make it a singular z. And then 512 gets us positive 8. Now what we do next is we have our 2 values here. So we put those values in one term. We keep our common factor on the outside. And we put this positive 3z and positive 8 in one value. And now we have to follow this formula. It's not that complicated. For the second term, what we do is we square the first number, right? A squared. So we square this. 3z squared gets us 9z squared. All right? And now for this middle term, we have to multiply this a value with the b value. So we have 3z times 8 gets us 48z. Don't worry about the signs yet. We'll get to that, all right? And then we take the last value, the b value, which is 8, and we square that to get 64. Now, the next thing we have to do, which is the last step, is we have to determine the signs of this second value. My hand's getting a little bit cramped holding it in this position, but so we remain with our common factor with our first term, and for this, for the sake of this video, assume that this a value, or the a squared, and the b squared are always positive, okay? And if you have any negatives in the expression, put them in this first term. We'll get to that after, but this is just a general idea, right? So these two are always going to be positive. And now for this middle term, you look, I put a negative here, right? And I wrote the opposite of the sign in the first term. Now, in this first term, if there are any negatives at all, right? If this is negative 3z or negative 8, right? If it's negative 3z plus 8 or 3z minus 8, then this sign will be positive. Because they're both positive in this bracket, then this sign is negative. All right? So those are just the pretty basic steps on how to do this. And just in case you're wondering about how well this works in the expanded form, I've done it over here, right? So we do this 3z times 9z, 27z cubed. 3z times negative 24z gets us negative 72z squared. 3z times 64 gets us 192z. And then we go to the second term. 8 times 9z squared gets us positive 72z squared. And since this is a positive 72z squared, this is a negative, we can just cancel those out. And then this 8 times negative 24z squared gets us negative 192z. And the negative cancels out with a positive. And then we have 8 times 64, which gets us our last 512. And that becomes the expanded form. That's just if you're curious. And if you have time to double check your answers, you could always expand it and make sure that you're doing it right. So let's get into some practice problems. So let's look at this question, all right? Negative 64x cubed plus 125. Now, if you look for a common factor, you will not find one. It is just not there at all, you know? Pretty nice. Actually not really, but you know, it's something. And so what we can do is, since we know there's no common factor, we go over to our calculator, we go 3, and then second function, that, yes, just making sure that it looks good on the video, and then 64. Actually, let's put negative 64. Because, yeah, why not? Right? And we get negative 4. Okay. So negative 4. So we can start with our first bracket. Hold on, I gotta hold this down. Okay. So first bracket, we have negative 4. Right? Because we always put the cubed root of the value in the first bracket, and then we put an x. Right? Because the cubed root of x cubed is just x, you know. All right, and then we go back to here. And you should probably do this check before writing anything down, but whatever. And then we go 125. Press equals and we get 5. So this is positive 5 because it's positive 125. We get positive 5. So that is our first term. Now, if you remember, in our second term, or a second factor, I should say. The first term is always positive, and we always keep the negatives in this bracket, right? So we keep this negative 4x in this bracket, all right? We don't put like negative 64x x squared, no. We keep the negative in the front bracket, all right? And then, so we go negative 4x squared, which is just 16x squared, right? It's positive. And then we can, yeah, so negative 4x, actually we disregard the sign in this one, all right? Because we're going to do the signs later. So 4x times 5 gets us 20x, right? Because 4 times 5 is 20 and then x, right? Disregard the sign for this one. We'll put in the signs later. And then 5 squared gets us 25. Okay? Now, this 25 will be a positive, because it always is. And now, I told you, in this first term, if there are any negatives, see, this negative 4x, that's a negative, right? If it was negative 5, that would also be a negative. If there's any negatives in that first term, that's a positive. All right? That is my rule of thumb. And I'm actually not sure. If both numbers are negative, what would happen? Actually, give me a bit. Okay, so I just ran a quick little experiment as to what to do if both signs are negative, right? You get a negative 4x and a negative 5. So if you just you have to put a negative here for this one, just in case you were wondering, right? I expanded it, right? And then positive 80x squared, negative 100x squared, negative 80x squared, cancel, and then positive 100x, cancel those out, and then negative 125, right? So if both of these are negative, then this one will also be a negative. So just keep that in mind as just like a random kind of fact, right? But since only one of them here are negative, this one is a positive. And if we expand this, I've done it over here, you can see that it was expanded properly, and you can expand it for yourself if you don't believe me, but I expanded it, and we got all these central terms canceling out, and we just got negative 64x cubed and 120 plus 125. So let's do another question. Let's go on to this one. You can do some of these on your own, any ones that I don't do. But let's just move on to this one, because actually, no, we'll go on to 3. You can do 2 on your own. But we're going to do 3. So, this one starts with something that doesn't have the variable, right? Because this has the variable, the x cubed. So it just starts with this instead. But really, there's no variance in our answer, right? I probably should not clear that. That's good to have. Okay. All right. 3 times the square root bracket, and then 1 gives us 1, right? 1 times 1 times 1 is 1. Obviously, we know that. And then this next one is 125. Actually, I should put... All right. And that gets us negative 5. Okay. So we know because this one is a positive, we put a positive 1 there, just a normal one. And then negative 5x, because 5x is the cubed root of this negative 125x cubed. And then for the second term, what is 1 squared is just another 1. And then 1 times 5x gets us 5x. Scintillating stuff here. And then this last term gets us 5x squared, which is 25x squared. All right, and then we close the bracket. This second term is always positive, and because there is a negative in this bracket here, this sign becomes positive. All right. again, it's like difference of squares. You know, there's one positive sign and one negative sign, right? And I guess you can look at it in this question, right? If they're both negative, these two negatives kind of cancel out, you know? So this is like having a positive bracket, right? Because two negatives, like if you multiply two negatives, you get a positive, right? So you can like count this bracket as only having positive signs, then have a negative in the next one, right? That's another way you can think of it, right? Because it's difference of squares, one positive, one negative, right? And then I have the expanded form here. All right, you can expand it on your own, double check my answers. I mean, I took like took like 5 minutes to learn this, so I might not be exactly correct, but you know, I do my best. And then let's go down to this question 4. Now, over here, we take out our calculator, right? Now this one might look a little bit scary because there's just a second variable, but really there's no difference. We just add in another variable, right? Into our first bracket. We just have our x and then we have a y, right? We'll figure out the numbers and the sign in between them, but like the cubed root of y is just, or the cubed root of y cubed is just y. Cubed root of x cubed is just x, right? So yeah. And then we go over here, we throw in the 8. We figure out that it's 2, so 2x cubed would be 8x cubed. And then we go over here, put negative 27, and we get negative 3, so negative 3y. All right, and then, so that's our first bracket. And then our second bracket is going to be 2x squared, which is 4x squared. All right, and then first term times second term, disregarding signs. So 2 times 3 is 6, and then x times y is xy. So 6xy. And then the second term squared, which just gets us 9y squared. All right. Now this sign is always positive. Same with this one. And because there's a negative in this question, we put a positive here. One positive sign, one negative sign. And if you want to check, this is the expansion with the canceled out terms. So yeah, that is pretty much how to do the cubed root stuff. And I'd also like to say something like while I have your attention, because this is something that people do that really pisses me off, right? So let's say you get 5 out of 8 in one section in a test, right? And then you get 24 out of 25, and then you get 16 out of 20. All right. Now what I find people will do, stupidly, is that they will just add these top numbers up. And then they'll say, ooh, 5 plus 24 plus 16. All right, that gets me 45. Okay, 45, all right? So 45 is the amount of marks that I earned. And then 8 plus 25 plus 20, that gets me 53. So I got a 45 out of 53 on the test. 45 divided by 53. Oh, I got an 85 on the test. Me. If you do that, you're stupid, okay? That is not how it works. You cannot add fractions that don't have the same denominator. It'd be fine if it was like 5 out of 10, and then 9 out of 10, and then 8 out of 10, right? Well, like, even then, it's like, no, I think this would be fine. If it was all the same denominator, it'd be fine. But really, you should do it in your calculator as having brackets around these. And this is what I mean, right? So you go into your calculator, you put bracket 5 divided by 8, because that is the percent that you got in this section. Okay? So 5 out of 8 plus 24 divided by 25, all right? Because that's what you got in this section, plus Actually, hold on. I gotta put the bracket. I'm stupid. 16 divided by 20. Because this is the percentage that you got in each of the categories. And you put equals. Alright, great. So then you divide this by the total number of sections, which is 3. Then you do this times 100. You got a 79.5%. This is copium. This strategy is copium. You got a, what is that, 5 out of 8. You got a 63 on this section. Yeah. How do you get an 85? How do you get an 85? You don't, right? You get an 80 in this section. And then 24 divided by 25 is what, 96? Yeah, 96. This is just copium. This is copium. This is copium is what it is. It is just copium. This is not how you count the marks. It doesn't matter how much is total inside a test. You have to calculate your percent for each freaking row. Because guess what? Guess what, right? If you get 99 out of 100 in one section, and then 4 out of 4 in another, right? And then another person gets 100 out of 100, and then 3 out of 4 in this section. You lose 1 mark either way. So this is 103 out of 104. And this is 103 out of 104. But this doesn't work because losing a mark on this is much less taxing than losing a mark on this. Way less taxing. Like, look, if you just do 103 divided by 104, you get 99. So these people are allegedly both at a 99. But no, that's just not right. So in the first section, you get 99 divided by 100. Plus, and then you could just do 1, because 4 divided by 4 is 100, so that just gets you 1. Divided by 2 times 100. You got a 99.5. So you actually got higher than the original one, thinking that you got just a 99.0, right? You actually got higher. But if you go here, 100 over 100 is just 1, plus, and then 3 over 4 gets you 1.75 divided by 2 sections times 100. You get an 87. 87.5. These are 2 different marks because these sections are different. Because they don't have the same denominator. These are different sections. You cannot just add the top number and add the bottom number. This is why you people get 50s in math. Because you can't even calculate your own mark properly. Jesus Christ, this is something that people do that pisses me off. Anyways, that's the end of the video. Yeah, that's it. Alright, bye. I'm gonna go like smoke some more meth because I smoke some more math, yeah. The DEA will never catch me. Alright, bye.